As we have seen in our previous module that stainless steel is our choice to utilize for the construction of industrial scale and pilot scale fermenters due to its properties like non-corrosive, resistant to the acids, resistant to the seawater, and having other engineering properties. But as concerned the type of the stainless steel, because stainless steel is graded as compared to with respect to the percentage presence of chromium, nickel, molybdenum and other ingredients. So here you can see that as concerned American Institute of Stainless Steel, so grade 316 grade that contain 18% chromium and 10% nickel and then 2 to 2.5% molybdenum. But as concerned this grade, so when there will be acidic fermentation, especially in case of citric acid, so when there will be a citric acid fermentation, pH in a high citric acid production dropped up to 1 to 2, so that highly acidic conditions. So in such case 316 grade stainless steel cannot withstand that properties which we required. So in that case there is an grade which called as 317, so that only contained by the excess addition of molybdenum, mean 3 to 4% of molybdenum, that increase the quality of 316 and that is graded up to as 317 grade. So 317 grade fermenters material that is mostly used for the fermenters if that will have to use for the acidic fermentations. But in some cases when we talk about the 304 grade that contain 8.5% chromium, you see here in 316 and 317 the chromium percentage is 18% and nickel having in 304 and 316 that is same, but in 304 there is no more molybdenum. So just by the addition of molybdenum that also increase the cost, but just by putting more molybdenum then we have a good quality stainless steel that can be used for the construction of the ferment. So in this slide you can see the different compositions in case of 302, 303, 304, 304 copper, 316L and 316Cb, 317L. So reported by the different what will be the ratio of what will be the percentage of carbon, sulfur, silicon, chromium, nickel, copper, molybdenum and etc. So these are the different concentration that is present, but the most critical is 316 and 317 that is mostly used in a fermenter. But a low quality we can say the cheaper fermenters 304 grade is also used for the normal fermenters, but high quality fermenters that have only grade 317. So when we have decided that will be the material, but the thickness of that construction material is very critical while designing a fermenter. Why that is very critical? As the thickness of the material will increase, then the cost will increase. The negative impact of the high thickness is that cause the problem while maintaining the temperature, because we will talk about in detail that what will be the procedure and what will be the mechanism for controlling the temperature. So as well as the thickness of that material, then there will be conduction of the heat rays from the outside to the inside, and then there is again the vice versa of that. So the construction material along with the thickness of the material is very, very critical. So as reported in the literature, so as concerned that when we talk about the fermenter having 3 lakh capacity to 4 lakh capacity, 4 lakh liter capacity, 7 mm plate may be used for the side vessel. But as concerned the top plate, that is 10 mm. So that's mostly. So 7 mm plate is used for constructing the side walls, but as concerned the top plate and the bottom plate, that is mostly having the thickness of 10 mm. So that is suitable. And the major thing as concerned when we say that there is 10 mm, that not have a flat, that should be in a spherical, because it is very good in a dimension having keep the semi-spherical bottom as well as the top, rather to have a flat surface or a bottom. So it is very critical while talking about the thickness of the fermenter vessel.